There we have a system of simultaneous equations. Examiners have a way to play hide and seek with simultaneous equations. There is usually a simpler way out than what we would capture at first glance. Taking a second look at the system will reveal that the coefficients of y are additive inverses. They have different signs but are the same in value. Adding them will result in 0. We may therefore go ahead and add the two equations, eliminating the y's. So we have a positive 2 here and we have a negative 2 there. If we add them together, the result is 0. We may go straight ahead and add the two equations. I am sure that some students will see it a little bit simple also, not simpler, will see it simple to just multiply this equation by 3 and then find the difference, which may be simpler than what we would expect, but they're simpler still, with the coefficients of y being additive inverses. So we add the two equations and the y's are eliminated. 3x plus x is 4x, and 13 plus a negative 1, which is 13 minus 1, is equal to 12. We have 4x and 12. Dividing the equations by 4, the x will be the only thing left on the left hand side. The 4 will be eliminated, and 12 divided by 4 is equal to 3. So x is equal to 3. Take that result, which is x is equal to 3, and substitute that into equation 1. So in equation 1, where we see x, we replace that with 3. And then of course we have 2y is, and then 13. So we have 3 times x, which is x is 3. So 3 times 3 plus 2y is equal to 13. And of course 3 times 3 is equal to 9. So we have 2y is equal to 13 minus 9. So 2y is equal to 4. And y is equal to 2, dividing through this equation by 2. So x is equal to 3 and y is equal to 2. As in all cases, when solving a pair of simultaneous equations, we may eliminate either the x's or the y's. We should progress, making use of any loop of simplicity that exists. Whenever we are manipulating positive and negative numbers, it is always easier to add than to subtract. Making use of additive inverses when they exist or are easily created is usually a simpler route. So making use of additive inverses, I always try to do that if it is an easier way out. If we see additive inverses, then we make use of them. If they are easily created, then we create them and then we move straight ahead. But we always try to make use of any what we call loop of simplicity that exists. Although it might not be so in all cases, examiners more often than not make it at least a little more time consuming to eliminate the x's than the y's. This technique is for candidates who are programmed to invariably eliminate the x's. Do not forget that 2 takes longer than 5. It is better to take an extra 5 seconds to examine a pair of simultaneous equations than an extra 2 minutes to solve it. So a system of simultaneous equations, it is better for you to take an extra 5 seconds to examine the system than to take an extra 2 minutes to solve it. Now we are about to factorize completely, and this first expression to be factorized is in the form of a difference of two squares, everybody's favorite. It is required to be factorized at site. Usually, we imagine that it attracts only a single mark in the examination, factorizing a difference of two squares. Therefore, we do not imagine that it should take 3 steps in entirety. So, there we have it. X squared is the square of x. X occupies the first position in both pairs of brackets. So we have x there and we have x there. Also, we need to know what we squared to give 16. 16 is the square of 4. 4 will occupy the second position. And in the end, we will place a negative sign in one bracket and a positive sign in the other. And the order does not matter. That is, if we put plus here and negative here, or put negative here and plus there, then it will not matter, as long as the two signs are not the same. And that is our answer. Now we have our expression, 4 terms. We will use factorization by grouping. So for this expression, we may factorize in pairs, then factorize the expression as a whole. So we have that, which is, as a matter of fact, being a little bit elaborate, because it is not completely necessary to include this intermediate step, but I'm just including these steps. We'll have another one in order to make the process clearer. So we are actually taking the common factor of x, and then we are dividing each term by the common factor. So the common factor, what is common in 2x squared and 3x? X is common. So we take the x here, and 2x squared we divide by x, and also 3x we divide by x. Also, what is common in 8x and 12? 4 is common. Generally, we take the highest common factor because we are in the habit of factorizing completely, and that can only be achieved if we take the highest common factor. And we say now 4 into 8x there, so 8x divided by 4, and also we take the 12 and we divide that by 4, and that is the result. So we have 2x squared divided by x is 2x, 3x, the x is cancelled, 8x divided by 4, 4 into 8 is 2, and there's nothing else. Then we say 12 divided by 4 is 3. Right. And there we have common factors again. So we will take the common factor and then divide by the common factor. So we will factorize a bit further by taking a common factor of 2x minus 3. So we have x, 2x minus 3 right there, and we divide that by 2x minus 3. Then we have 4, 2x minus 3, we have it here, then we divide by 2x minus 3. So we take the common factor and we divide each term by the common factor. Of course, these will eliminate each other, and we have x. These will eliminate each other, and we have 4. So we have 2x minus 3 and x plus 4. And that's all there is to it. So we have a total of 28 tickets. X were for adults, and the number of tickets for children must be the remainder. So X were for adults. So what do we imagine? If we have 28 tickets, X were for adults, then what do we imagine? If we have 28 tickets and we have 8 of them for adults, how many will be for children? We just take away the 8 from the 28. It is the same thing here. If X were for adults, then what will remain? 28 minus X for children. The amount spent on adult tickets must be equal to the cost of each ticket, which is $30, multiplied by the number of them. So you take the number of them and multiply by the cost of each one. That's not very difficult. So 30 multiplied by X. And what about for the children? The same applies here as in Roman 1b above. The amount spent on tickets for children is equal to the cost of each one, which is $15, and we multiply that by the number of them, which is 28 minus x. So we take the cost of each one, which is $15, and that we multiply by the number of them, which is 28 minus x. So 15 multiplied by 28 minus x. The total spent on tickets must be the sum spent on adults' tickets added to the sum spent on children tickets. The total will be the amount spent on adults' tickets and add that to the amount spent on children. There we have it. And we are required to simplify that expression. So we take that 15 and we multiply that by 28. When I'm required to do something like that, I can do it mentally. I usually say 15 and treat it as 1.5. So we say 1.5 times 28. 28 is 28. A half of 28 is 14. 28 plus 14 is 42. But do not forget that it is not multiplied by 1.5, it is multiplied by 15. Therefore, it is not 42 but 420. And of course, 15 multiplied by x is 15x, and this will return as it is. I can imagine before the next step we realize that negative 15 plus 30, which is, of course, 30 minus 15 is 15. So, in the end, we should have 15x plus 420, or 420 plus 15x. And that is the amount spent overall. To find the number of adult tickets, which is x, as we have it right up here, to find the number of adult tickets, we may equate the expression, which is the one that we have arrived at right here, that expression in x, we may equate that expression in x for the total number of tickets, right, and that we will equate to the known amount of money spent on those tickets. Of course, that is given to us in the statement of the problem. So we equate the expression for the total number of tickets that contains x to the known amount of money spent, and we'll be able to find x there. Of course, we will eliminate this 420 first by subtracting 420 from both sides, in which case from the left hand side 420 will be eliminated, and here we have 660 minus 420, and that will be 240. There we have it. And that is equal to 16. Sometimes I like to exercise my brain, especially when I see a number like 15. X is equal to 240. I'm saying to myself, what number do you take 1.5 times, because 1.5 is related to 15, and the result is 24? Then it is easy to see that it is 16, because half of 16 is 8. 8 plus 16 is 24. So I can do that mentally and say x is equal to 16.